Hey, what is going on, Math 1? This is Mr. Bainey, and we're going to take a look at lesson 12.2, Graphing Systems of Linear Inequalities. This requires that you know how to graph inequalities, linear inequalities, and that's going all the way back to module 7. I believe it's lesson 7.3, where you graph a line, you know whether to make it solid or dashed, know what that means, and then you're going to shade your solution, whether that's shading below the line or above the line. And so we're going to just go straight to some examples, but read through the first part here talking about what a system of linear inequalities is, what the solution means. On the bottom of page 549, let's take a look at these problems on the bottom. So we're going to graph the system of linear inequalities, give two ordered pairs that are solutions and two that are not solutions. The first inequality is y is less than or equal to x plus 3. That is like looking at y is equal to x plus 3. This is in slope-intercept form. The y-intercept is 3, so we start at 3 on the y-axis. The slope is a 1, since there's no number here. We treat that as a 1x. So that means our slope is going to be a 1 over 1. So here I'm going to start at 3. If I go up 1 over 1, I get there. The scale here goes by 2s as I go up and down, left and right. So this would be a slope of 1, remember starting at the y-intercept of 3. Okay. I can also go backwards. I'm going, as you can see here, instead of going up 1, right 1, I'm going down 1, left 1. I still end up on the same line. And that's my line. Okay, something like that. Now, I actually drew the line first on accident. Meant to mention that I do make it a solid line because the symbol here, our inequality symbol, it includes the equal to. Equal to means that it's okay if y equals x plus 3. And that's the line, the actual boundary line. So that means everything on this line is a solution to that inequality. Now we want to figure out when is y less than x plus 3. So we can test a point, and I'm going to put it in blue here. Our best test point that we could do is the point 0, 0, not the best, but the easiest. So if we test 0, 0, it's as easy as just plugging in 0 for x, plug in 0 for y, and see if it's a solution. So instead of y is less than or equal to x plus 3, it's 0 less than or equal to x plus 3. Is that true or false? Well, 0 plus 3 is 3. So 0 is less than 3. This is a true statement, which means 0, 0 is a solution. Okay, again, looking at your graph. This blue point is a solution to my inequality that I graphed. And that means I shade all of that. Now when I do my other line, let's do it in a green color here. I'm going to do y is less than negative 3. That's the same as graphing y is equal to negative 3. This line is a special type of line. It's going to be horizontal, and that's because y equals negative 3 means all the y coordinates are negative 3. So if I start at negative 3, like 0, negative 3, negative 1, negative 3, 1, negative 3, or sorry, that was 2, negative 3, 4, negative 3, 6, negative 3, and so on. Because I don't have the equal to part, that means y can't equal negative 3. Then this is a dashed line. So I just dash all the way across. So everything on the green line is not a solution. It's not a solution to our y is less than negative 3. Now I want to look at if y is less than negative 3, plugging in 0, 0. Is 0 less than -3? It is not. That's false, which means I'm going to shade the other way. So again, look at the blue point. The blue point, 0, 0, is not a solution for our green line. So I don't want to shade that side. I want to shade below. So it's going to look like this. Okay. Now we just look at what's overlapping from what I shade. What would be easier is if you use two different colored highlighters and you just highlighted the two different sections that I did instead of kind of scribbling it and sketching it. It's easier to see visually. I'll try it on the next one as well, using some highlighters. But it's going to be something like this. It'll be this area that I'm highlighting in yellow. These are our solutions to the system. Okay, it's where the red and the green overlap. And when we look at what is a solution, well, if I go to the point, let's say 0, -6, that is over here. 0, -6 is right here. It is in this yellow highlighted area. So it's a solution to our whole system. Also, another one could be 6, -8. And that would be over 6 down 8 would be right over here. Things that aren't solutions would be something like 0, 0. Okay, it's a good one to think about because 0, 0 is a solution to the first inequality, but it's not a solution to the second inequality. So therefore, it's not a solution to the whole system. Remember, to be a solution to the system, it has to be a solution to both things. So that isn't one. And then if I can just go to the area that I didn't shade at all, something like -4, 6, which would be up here. -4, 6 would be up here. That is definitely not a solution. It's not a solution to either one. So therefore, it's not a solution to the system. Go try number 4. That's a good one for you to practice because one's in standard form, one's in slope-intercept form. Give it a try and pause it. The solution will appear in a few seconds. And here is a solution for number 4. I graphed the first inequality. Y is greater than x minus 8. The line is y equals x minus 8. It's dashed because it doesn't have the equal to. It's this red line right here. So it starts at -8 as our y-intercept. It has a slope of 1. So it looks like that. Just like this other red line here for number 3 also has a slope of 1. So it's the same steepness. Test it out for y is greater than x minus 8. 0 is greater than 0 minus 8 is a true statement, which means I'm going to shade above. So this red line, everything above. So it's this red and blue area together. Then 2x plus 4y is less than 16. Same thing as this equation right here to graph the line. I did a x and y intercept, which means if I cover the 2x up, I cover it up because x is 0, which means it's gone. So 4y is 16 means that y is 4. So that's the first point you see here, which is this point on the graph. And if y is 0, that's gone. That's equal to 0. 2x equals 16, and x is 8 in that case, which is going to be this point over here. That's also dashed line for the same reason as the first one. And then I tested, is 0, 0 true? 0 plus 0 is less than 16 is a true statement. So this green line I shaded below in green, and that's this blue area and this green area right here. And so both the red and the green shading that overlapped created this overlap right here, and that's our solution. So everything in blue is a solution, but remember that this is dashed and this is dashed. So The points on the line aren't solutions. It's just everything inside of here, including 0, 0. So I'm not going to write down solutions and not solutions. Just know that 0, 0 is a solution to the whole system in this case, and something like 8 comma 6 would not be a solution, or 8 comma negative 6 would also not be a solution. Okay, I'm just going to show you one of these here, and if you'd like to try the other one, I'll have that solution up as well. So on the bottom of the next page, let's take a look at number 5. I'm just going to graph these pretty quickly and shade it using the same exact process that we did on the previous problems. So y is less than or equal to negative 2x minus 3. I start at negative 3, and then it's a slope of negative 2 and over 1. Negative 2 over 1. Negative 2 over 1. It's a solid line. So I'm going to also, just to make my line accurate, add some more points here. Same slope. Instead of going down to right 1, I can go up to left 1. And I get something like this. Again, solid line. The other line, I start at 1, and it's the same slope. So down 2, right 1. Or I could go up to left 1. And you know what? I forgot the shade. So let me do that for both of them. So the one on the left was my first line. The one on the right was my second line. If I test a point, is 0 less than or equal to 0 minus 3? That is a false statement, it looks like. So I want to shade for the first line, everything to the right, sorry, to the left, because 0, 0 is not a solution. That's a false statement. Then the second line, if I test at a point, is 0 less than or equal to 0 plus 1. Looks like that is true. Yeah, so let's shade that green. That's this area, and it's going to change the color of my red area as well. But if you can see, if I shade everything below that second line, it includes all this red. And therefore, everything in this kind of darker green area is my solution because it's overlapping. So what that means is everything that's a solution to the first line, that's this one right here, if it's a solution to that one, which is this dark green area, it's a solution to the whole system, okay, because they share that area. So to describe the solution, it would be something like solution to the system would be the same as the solution to the first inequality, which is y is less than or equal to negative 2x minus 3. So if it's true for that inequality, it's true for the whole system. Again, you can tell just by the shading part. Okay, you'll see the solution for number 6 if you'd like to pause it in just a few seconds. And as you can see for number 6, the first inequality graphed at the bottom of the graph here, dashed line, starts at negative 6, has a slope of 1 going up 1, right 3. Looks like that. It shades below because I could test the point 0, 0 is not a solution. 0 isn't less than 0 minus 6. And the second inequality starts at 5, also has a slope of 1/3. As you can see, same slope. They're parallel. And then y is greater than or equal to 1/3 x plus 5. Testing 0, 0 would be 0 is greater than 0 plus 5 is also false. So I'm going to shade on the other side of 0, 0. So this means that there's no solution. Since they are parallel and don't intersect, they're never going to intersect their areas of shading, the solutions for each one. And so they'll never have the same solution, the red area and the green area. So there's no solution to the whole system for this particular one. Okay, that's it for this lesson. Thank you so much for watching. I hope it was helpful. Practice that graphing. Um, if you still struggle with it, and then worry about the dash solid versus solid, and then the shading up or down, making sure you know how to test points, and also to identify what your solutions are to the system. Okay, thanks so much again. Have a good day. Appreciate it.